Welcome students for the general principles and process of isolation of elements. In this video, we shall be studying about introductory part of isolation of elements. So let's proceed. Modern periodic table of elements. In this, already students, you have studied about Group 1 and Group 2 elements, that is alkali metals and alkaline earth metals, belong to S block elements, whereas Group 13 to Group 18, that is up to noble gas, so it belongs to P block elements, whereas Group 3rd up to Group 12, so these elements belong to D block elements, whereas lanthanide and the actinide series belongs to F block elements. Let's proceed with some of the general principles involved in the isolation of elements. First question which arises in our mind is, what is metallurgy? And the answer for this, students, is the scientific and technological processes used for the isolation of metals from their respective ores. It can be called as metallurgy. And we can consider one example, that is hematite ore. So iron is extracted by the reduction of hematite ore using coke or else by using carbon monoxide. Metals can be classified into reactive metals and less reactive metals. So examples of the reactive metal, students, is sodium, which belongs to Group 1, that is alkali metals. Next, magnesium, iron, zinc, aluminium. So all these metals are highly reactive in nature. So very easily they would be giving electron. Whereas in case of less reactive metals, for example, silver, gold, platinum, copper and even mercury. So silver, gold and platinum, as you know, they are noble metals, so their reactivity is extremely less, but even student, copper and mercury are also less reactive in nature. Okay, so the next difference is reactive elements easily attacked by the oxygen, water and carbon dioxide. So reactive metals can easily get corroded, that is oxidized. They can be reacted with the water to form hydroxide of the metals, or else, student, they can even react with the carbon dioxide to form carbonates of the respective metals. Whereas all this is not observed in less reactive metals, that is oxidation, hydration followed by the reaction with the carbon dioxide is not observed for less reactive metals. And when reactivity of metals are very high, so they cannot be obtained in the pure form, okay, from the nature. From the nature, reactive metals can't be obtained in the pure form. Whereas, student, less reactive metals, so they react less with all the reagent, that is oxygen, water, carbon dioxide, so they can be easily be obtained in its native form. Okay, and reactive metals should be isolated by using various techniques which would be discussed within this chapter, whereas the less reactive elements can be very easily isolated from its native form. We shall understand some of the terms which are used in this chapter. So the first one, students, is minerals. Minerals are naturally occurring materials containing metals or metallic compounds obtained by mining process. For example, the minerals of iron are hematite ore, which is Fe2O3 ferric oxide, magnetite, that is Fe3O4 triferric tetroxide, limonite, that is ferric oxide trihydrate, siderite, and iron pyrites. So all these are minerals of iron. Let us study about types of minerals. Minerals are of many types. The first one, oxide minerals. Example, ferric oxide and zinc oxide. Second type of mineral, students, carbonate minerals. For example, zinc carbonate and calcium carbonate. Third type, sulfides minerals. Example, iron sulfide and zinc sulfide. Fourth type of mineral is sulfates. Example for this is magnesium sulfate heptahydrate. Next one, silicates. Example, aluminium oxide silica dihydrate. The next type, halides as a mineral. Example, sodium chloride, potassium chloride. And the last type are nitrates. Example, NaNO3, that is sodium nitrate, and potassium nitrate, KNO3. Let us continue, student, with the next term as ores. Ores are the minerals from which metals can be extracted conveniently and economically. So all the ores are what, student? They are the minerals. So from the minerals, if the metals are being extracted conveniently as well as economically, then such a mineral are called as ores. For example, hematite is a mineral, but it can be called as an ore. Why? Because it is used for the extraction of iron. Let us discuss about minerals of the iron. So iron, students, it is having 4 different types of minerals. The first one is magnetite, that is triferric tetroxide, Fe3O4. The second one is hematite mineral. The formula of it is ferric oxide, Fe2O3. Third one is siderite, which is ferric carbonate, and the fourth type is iron pyrites, FeS2. Among all these 4 minerals of iron, hematite mineral is called as an ore, and thus, student, we are extracting iron by using the hematite ore. It would be discussed in detail later in this chapter. Let us understand now one more term which we would be using in isolation of elements, that is matrix or gangue particles. The unwanted impurities such as mud, stone, sand, etc., which are present in the ore particles are called as matrix or gangue particles. For example, students, Silica is the gangue in the hematite ore. Silica means SiO2, whereas ferrous oxide, FeO, ferrous oxide is the gangue which is present in copper pyrite ore. All the ores are minerals, but all the minerals are not the ore. And the reason behind this is all minerals are not used for the extraction of the respective metals. So always you need to remember, student. So ore would be one kind of the mineral itself, but the mineral from which metals are being extracted, so that particular mineral would be called as an ore. So you need to remember all ores are the minerals there, whereas all minerals are not ores. Then one question arises in your mind, why not all the substances that contain a metal cannot be used for the extraction? So the answer is very simple, because the method should be easy and profitable one. For example, student, if we consider the mineral in which the percentage of the metal is very less and the expenditure on the extraction process is enormous, then that particular mineral won't be selected as an ore of the given metal. Thus, the main reason for this is the method should be easy and the profitable one for selecting the ore from a list of minerals. Let us consider some of minerals and ores of a few metals. And the first one, iron. Hematite is a mineral of iron with the formula ferric oxide. Magnetite is the second mineral of iron with triferric tetroxide. Limonite, that is ferric oxide trihydrate. Iron pyrites, FeS2. And the fifth one, siderite, that is ferrous carbonate. So we are having 5 different minerals of iron. Among these, hematite is an ore of iron. So next we shall be considering the minerals of zinc. So the first mineral of zinc is zinc blende, that is zinc sulfide. Second mineral is zincite, formulae zinc oxide. And the third mineral, calamine, which is zinc carbonate. So students, among these 3 minerals, the first one, that is zinc sulfide, is considered as an ore of zinc. Let us continue. The third metal is copper, and for copper, students, first mineral is copper pyrites, the formula CuFeS2. The second mineral of the copper is malachite, that is cupric carbonate, cupric hydroxide. The third mineral is cuprite with the formulae Cu2O, that is cuprous oxide. And the fourth mineral of the copper is copper glans with the formulae cuprous sulfide. Among all these 4 minerals of copper, the first mineral, students, that is copper pyrites, is selected as an ore for copper metal. Now let us consider aluminium metal. There are three different minerals for aluminium, and the first mineral is bauxite with the formulae aluminium oxide dihydrate. Second mineral of aluminium is cryolite with the formula Na3Al(F6), whereas the third mineral of aluminium is China clay, and the formula student for this is Al2O3, that is aluminium oxide silicate dihydrate. And among these, bauxite is considered as an ore of aluminium. And the next metal is magnesium. In case of magnesium students, we are having three different minerals. The first one is magnesite with the formulae magnesium carbonate MgCO3. The second mineral is dolomite with the formula MgCO3CaCO3. So both the carbonates, that is magnesium carbonate and calcium carbonate, both are present in dolomite. The third one is Epsom salt with the formulae magnesium sulfate heptahydrate. So among all these three minerals for magnesium, the second mineral, that is dolomite, is selected as an ore for extraction of magnesium students. Let us discuss now general principles of metallurgy. The various steps that are involved in the extraction of pure metals from their respective ores can be broadly classified into four different groups. And the first one is concentration of ore particles, and the second conversion of ore particles into respective oxides or other kind of desired compounds, followed by the third step, that is reduction of ores to form the crude metals, and finally the last step, that is refining of metals. Let us consider one example for understanding of procedures involved in the extraction of a metal. So we are considering here hematite ore, which is of iron. So the selection of the ore which would be done from the minerals, followed by concentration of the ore particles, and next to this is extraction of iron, followed by refining process, and finally we are obtaining pure metal, that is Fe particles. So this entire, that is 5 steps, it would be involved within metallurgical processes. Thank you students. In the next video, we shall be studying about concentration of the ore particles. Thank you.